pH range of 0 to 7, reacts with metals and bases, has a sour taste and emits/contributes hydrogen ions into a solution. Water dissolves acids, which are substances that increase the concentration of hydrogen ions when dissolved in the water. We have a very powerful acid in our stomach, which is called HCl. This is one of the factors that might induce heartburn. In water, strong acids are entirely dissociated, resulting in a neutral solution. Their conjugate bases are not very strong. Weak acids only partly dissociate when exposed in water. Their conjugate bases are quite powerful. Whenever an acid-base reaction occurs, the equilibrium will prefer the reaction that transports the proton to the more powerful base unless otherwise stated.
A base includes sodium hydroxide, calcium carbonate, and potassium oxide. A base is a chemical reaction that utilizes an acid by reacting with hydrogen ions. The majority of bases are minerals that react with acid to produce water and salts. Metal oxides, hydroxides, carbonates are examples of base. How do you identify a base? To determine whether a substance is an acid or base, before and after the reaction, count hydrogen on each substance. If the number of hydrogen decreases, this substance is the acid. If the number of hydrogen increases, this substance is the base.
The neutralization reaction is also known as the acid-base neutralization reaction, or just the acid-base reaction. We define neutralization as the chemical reaction between an acid and a base. The acid and base are reacted away and neither remain. In their place, pure neutral water forms and also a salt product. Hence, the name neutralization is neither acid nor basic. It is the middle of both reaction. So, in the pH scale, neutralization is in the pH of 7. These are the following examples of chemicals produced by neutralization reaction: sodium chloride, magnesium hydroxide, and sodium biofluoride.
Acidity and alkalinity are measured with logarithmic scale called pH. Here is why. A strongly acidic solution can have 100 million or 100 trillion times more hydrogen ions than a strongly basic solution. Moreover, the hydrogen ion and the hydroxide ion concentration in everyday solution can vary over that entire range. In order to deal with these large numbers more easily, scientists use logarithmic scale, whereas pH scale. Each 1 unit change in the pH scale corresponds to a 10-fold change in hydrogen ion concentration. The square brackets around the H plus automatically mean concentration to a chemist. What the equation means is just what we said before. For each 1 unit change in pH, hydrogen ion concentration changes 10-fold. Pure water has a neutral pH of 7. pH values lower than 7 are acidic, and the pH values higher than 7 are alkaline.
What is the pH of a 4x10 raised to the power of -3? First, the formula. The formula is pH equals to negative log H plus. So, pH negative log 4x10 raised to the power of -3 is 3 minus log 4. The 3 is from the negative exponent 3. Bring down the log and 4. Then, bring down the 3 minus 0.6. And the pH is 2.4 lactic acid.
An indicator is a substance that changes its color in acidic and basic medium. An indicator show one more in acidic medium and different color in basic medium, so that they are called indicators. Acid-base indicators are generally weak protolytes that change color in solution according to the pH. The reactant side would be favored and there would be more acetic acid water in solution. Because acetic acid is a weak acid and water is a weak base. There are different types of indicators. Indicators derived from the natural sources are called natural indicators. Example, litmus and red cabbage. Indicators prepared in laboratory are called synthetic indicators. Example, phenolphthalein. Olfactory indicators are which give different odors in acidic and basic medium. Example, onion, vanilla, essence, and etc.
In summary, acid is any substance that in water solution that tastes sour. It changes the color of a certain indicator like the red and blue litmus paper. It reacts with some metals like iron to liberate an hydrogen. It reacts with bases to form salt, and it promotes a certain chemical reaction called the acid catalysis. A base is a chemical that can neutralize an acid by reacting with hydrogen ions. It do not react with metals, but it do react with acid. To determine whether a substance is an acid or a base, before and after a reaction, if the number of hydrogen decreases, then this substance is an acid. And if the number of hydrogen increases, then this substance is a base. Neutralization is a chemical reaction in which an acid and a base react quantitatively with each other. In a reaction in water, neutralization is a result in there being no excess of hydrogen or hydroxide ions present in the solution. It is in the middle of both reactions, so it is in the pH of 7. pH scale is a scale developed in order to determine how acidic or a base of a substance is. Value of the scale range from 0 to 14. Indicator is a substance that can changes of color in the presence of an acid or a base. Example of it are the litmus paper, cabbage juice, onion, and the phenolphthalein.